Alright, so today we're talking about special products. So we're going backwards from what we talked about exactly 3 weeks ago today. So these were the notes key. This is the notes key that we talked about. So remember that we had a square of a sum. And a plus b squared meant a plus b times a plus b. And if we FOILed it, we found that it always followed this pattern. So then we had examples. And we said that the result of a square of a sum, when I multiplied it, was a perfect square trinomial. And I pointed that out because it's going to be very important to us starting today. And then we had square of a difference. And we know that a minus b squared means a minus b times a minus b. And when we FOILed it, we got this pattern. And the result was a perfect square trinomial. And then our last special case when we were multiplying was the product of a sum and a difference, when we had a plus b times a minus b. And we said that result was a difference of squares. Is this coming back in your brain? Okay. So we're going to use this to go backwards today. When we have our special products factored, we are looking for those results. We are saying, hey, does anything match this pattern? For instance, if I had 4x squared minus 9, that is a difference of two perfect squares. So that's going to follow that pattern which we made of a squared minus b squared. And we could use our X puzzle to do this, but we don't have to because we remember this special case. We say, oh, the difference of squares, when it's factored, is the product of a sum and a difference. Here's a squared. What will I write here? A. This is b squared, so I will write plus b times a minus b. We're saying look for patterns such as this. The result will always follow this. So in this example, now I have 4x squared minus 9. I know that my result, if I factor this, will be a product of a sum and a difference. If this is 4x squared, what will I write here? 2x plus, this is 9, what will I write here? 3. What goes in the second binomial? 2x minus 3. And you know why this is, because there is no middle term, there is no x term, no linear term, no b term. B is equal to 0. So we know that it has to follow that pattern we talked about 3 weeks ago, where if we said we had a product of a sum and a difference, that our middle term would cancel out. Product of a sum and a difference, our middle term cancels out. Now we have a special case where we will see a perfect square trinomial. Remember, our perfect square trinomial pattern is the result from when we had a square of a sum. A plus b squared resulted in a squared plus 2 times a times b plus b squared. So when we recognize and we see perfect square trinomials, we can automatically factor them to the square of a sum when the middle term is positive. The square of a sum, what would that look like factored? A plus b squared. So when I look here, I say, making sure, is 4x squared a perfect square? Yes, and what's the square root? 2x. Okay. Is 9 a perfect square? And what's the square root? 3. So now I have to make sure that my middle term follows the pattern. 2 times 2x times 3. 2 times 2x times 3. That's 2 times my a term times my b term. What is 2 times 2x times 3? 12x. So this is a perfect square trinomial. And you've got to check that middle term. If you don't check that middle term, someone's going to get you. So I know that it is a square of a sum. And how do I know that it's a plus sign that goes right here? Because which part is positive? If this is positive, then this is positive. So this is positive, my middle term is positive, my sign is positive. Remember, if our middle term is negative, so if I see a squared minus 2ab plus b squared, what do I know if this follows the pattern? What will be my factored form of this polynomial? A minus b squared. So we look at this and we say, okay, this looks like it might be a perfect square trinomial. Let me check. What's the square root of 4x squared? 2x. What's the square root of 9? 3. I still have to check. Does this match negative 2 times 2x times 3? Yeah. Yes. So what is my sign in between these values? Minus, and it is squared. All right. So let's identify. Let's say, hey, is it a special case or special product? Can we factor it? So here on A, is this a special case? Why not? But why is this not special? Can I take the square root of 9x squared? What is it? 3x. Can I take the square root of 16? So why is that not a perfect square trinomial, Zoe? Because 7 is prime, and we know that this would have to be 2 times 3x times 4. So we should get 24x. If this was 24x, then this would be special, but it's not. Okay. What about b? Is b special? Let's check. What's the square root of 9x squared? 3x. What's the square root of 4? 2. 2 times a times b. 2 times 3x times 2. Do I get 12x? Yes. So this is a perfect square trinomial. What would my factored form be? 3x plus 2 squared. What about here? How come you know it's not special? 3 is not a square number. It's not a square number, so I can't take the square root of it, so that is not a special case. What about D? What do you notice about D? Before we even say it's a perfect square trinomial, it's got a GCF. Which, if you notice the GCF, if you're struggling with noticing if it's a perfect square trinomial or not, you can simplify it by taking the GCF first. What fits into all of those terms? 4. So we get 4 times 16x squared plus 8x plus 1. Which in this case, the numbers are smaller, so you're more familiar with them. You might be better equipped to find the perfect square trinomial. Also, because there is a GCF, if we ask you to factor fully, you would have to have that GCF pulled out. So, what is the square root of 16x squared? 4x. Square root of 1 is 1. Is 8x correct? Because 2 times 4x times 1 is 8x. So this is a perfect square trinomial. And if we factored it, we would have out our GCF. And then what? Okay, what about E? It might be a perfect square trinomial. You know, you look at this and you say, hey, that's a perfect square. What's the square root? 5x. What's the square root here? 7. So then we say, okay, I need to check. 2 times 5x times 7. Is it negative 70x? What is it? Well, that just means that this is a negative. If 2 times 5x times 7, that's 70x. So it is a perfect square trinomial. So what does that mean my factored form will be? 5x minus 7 squared. So that's where that negative goes. It goes in between. So this negative right here means that this will be a negative. If you wanted to get really technical, you could say, okay, well, this would be a negative 7. So 2 times 5x times negative 7 is negative 70x. Okay, what about f? It's a difference of squares. Because 81x squared, perfect square. What's the square root of 81x squared? 9x. What's the square root of 1? So what is my factor form? Nine x minus 1 times 9x plus 1. Does order matter? Ms. Webb, can I write 9x plus 1 times 9x minus 1? Yes. Do not put a plus sign between these two. We are multiplying. These are special products. What about g? How do you know? There's a negative on the third term. Do we see a negative on the third term in any of my examples? No, because the negative times a negative would give me a positive. So this right here says, hey, this is not special. I don't have to do any mental math to find out about 81, though we could, because 81 would not be my middle term. It's that negative right there that tells me this is not special. What about h? Not special, how do you know? Because it's not a difference of squares, it's a sum of squares. Can you still factor this? Yes, it has a GCF. What's the GCF here? 4. So you could factor out 4 and make 25x squared plus 4. Still not special. Okay, I want you to take 5 minutes of experiencing IXL, just special cases. I'm going to leave this here. Everything on IXL is either going to be a difference of squares or a perfect square trinomial. Okay, so those IXLs are going to be there for you when you want just straight up practice. Let's move on to the back. We're going to talk about special cases. They're double special. Okay, so go ahead and just put your screens half down. What about special cases? So looking here, what do we see? We're either going to see in special cases a difference of squares or a perfect square trinomial. Which one is this? It is a difference of squares. There's only 2 terms. So we know that our result is going to be a product of a sum and difference. What would be my first term in my binomial? N squared, because the square root of n to the 4th is n squared. What would be my second term? 16, because the square root of 256 is 16. All right. So what makes this a special case? We're not simplifying, we're factoring. But yes, we can factor again. What can be factored again? N squared minus 16 is a difference of squares. So though nothing will change with n squared plus 16, we can factor n squared minus 16. Because this is a difference of squares, I know my result will be a product of a sum and difference. What would be my first term in this binomial? N, because the square root of n squared is n. What would be my second term? 4. So n plus 4, n minus 4. Okay. So in this case, you have 3 binomial factors for r n to the 4th minus 256. Number 2, what do you see? What do we see there? A difference of squares. So I know that my result will be the product of a sum and difference. What will be my first term? 9x squared. What will be my second term? So 9x squared plus 4 times 9x squared minus 4. What do you notice? You can factor again. 9x squared plus 4, nothing can happen there because that is a sum of squares, so we just leave it. But this is a difference of squares, so we can factor it again. What would be my first binomial? 3x plus 2 times. Last special case. What do you see here? A perfect square trinomial. Does it have a GCF? So we can factor this. We say, what's the square root of 81x to the 4th? 9x squared. What's the square root of 16? 4. What's my middle term? What's my middle sign? Okay. And let's just double check that 2 times 9x squared times negative 4 should give me negative 72x squared. Yes, it does. So good. It is a perfect square trinomial. But what do you see here? It's a difference of squares. So we can factor again. But it's squared. Yeah, there's a couple ways we correct it. So what is my product going to be? 3x plus 2. 3x minus 2, but because this is squared, this is squared. Because really this says 9x minus 4, or 9x squared minus 4 times 9x squared minus 4. So this one would be 3x plus 2 times 3x minus 2. And so with this one, 3x plus 2 times 3x minus 2. So this would be the parentheses among parentheses is not the most simplified way to write something. So this would be the better way to write that. What you're talking about would not be wrong. Okay. Yeah. All right. Speed round. I'm going to give you 4 minutes. Identify the special case and factor using the pattern. Meaning, you should not be showing a lot of work here. If it is not a special case, leave it blank. That doesn't mean you can't factor it. I just want you to leave it blank for right now. Okay. So, only 2 were not special cases. The one that may have tripped you up is making sure that you saw the GCF on this first. And if you saw the GCF, then this one was a special case on the inside. So be careful with that with your homework. Any questions from special cases today?